So we work with layered semiconductor materials, and what we do there is you have a different semiconductor material, say gallium antimonide and indium arsenide, or combinations thereof. And what you do is you can tailor the thickness and the composition of the materials to make what are called wave function or quantum engineered structures. Basically, you can design them to get the wavelength of light out that you want. We're interested in infrared light. Why are we interested in the infrared? Because in the infrared, you can detect chemicals more sensitively, maybe 100 or 10,000 times more sensitively than you can in the near infrared or visible wavelengths of light. So that's particularly useful. Also, everything radiates. Night vision goggles, you think about things like that. We're looking at the radiation of engines on a ship or a plane. So you can use these as sources to divert heat-seeking missiles is another interesting application. We're also interested in biomedical applications where you can use infrared to detect oxygen levels in the body or glucose levels in the blood, things like that, in order to treat maybe aneurysms, detect glucose for diabetes management, and maybe do feedback for artificial pancreas or something like that. And so there's lots of biomedical as well as the chemical sensing applications and defense applications as well. So one of the other things we're doing, we want to make more efficient devices. So in trying to make more efficient devices, that means I want to get the most light out that I can for the minimum power output. One of the things that we're doing to try to improve that is to use graphene, which is a hexagonal two-dimensional layer of carbon atoms that has really excellent electrical, optical, and thermal properties, high conductivity. Those properties give us the opportunity to see through into a device or to apply a bias across a device. And we're using that not only to try to develop more efficient lasers, but also just fundamentally, what happens when I want to integrate a two-dimensional material with a three-dimensional material? How does that work? So there's just some fundamental interesting thoughts about how you would do that. And so we're studying them to make more efficient lasers as well as to develop new and novel devices.